Hello boys and girls. This is Professor Nelson from Electronics. This time, we're going to do a very interesting project that many of you will surely be able to use in your work. I'm talking about working with neon LED strips, like this one here. These come in different colors, as is the case with this LED strip. These are quite flexible with a fairly uniform brightness. These make the work done with this type of LED strip perfect. In addition to the LED strips, we'll need other materials. A 1 kilo quarter-watt resistor. A 470 ohm quarter-watt resistor. A 4.7 kilo quarter-watt resistor. A 5 kilo potentiometer. A MOSFET transistor, the IRFZ44N. And a heat sink for the transistor. Now let's look at the project circuit. Okay, this would be the circuit we're going to build. And here's where we'd place the neon LED strip. And here's our MOSFET transistor, the IRFZ44N. Normally, a transistor works as an electronic switch. However, that will depend on the signal received at the gate. And as we can see, here we have 3 components in series, 2 fixed-value resistors, and a potentiometer. Now, we're going to calculate the maximum voltage dropped across the gate. Therefore, the gate voltage will be equal to the sum of R2 plus the variable resistor. Divided by the sum of all the resistors. Therefore, the gate voltage will be equal to 470 ohms plus 1 kilo divided by 4.7 kilohms plus 470 ohms plus 1 kilo. This would be equal to 1.47 kilohms divided by 6.17 kilohms. All of this multiplied by the 12 volts of the power supply we are using. So the gate voltage will be equal to 2.86 volts. This would be the maximum voltage the gate will reach. What does this mean? It means that the MOSFET transistor will operate as a variable resistor, since the voltage will not exceed 4 volts. Now, if you want a MOSFET transistor to operate as a variable resistor, the voltage cannot exceed 4 volts. Therefore, this voltage meets that requirement. Now, this means that when we have the potentiometer at the minimum value, the bulb will remain off. And as we increase its value, the bulb will increase in brightness. This also means that a voltage will drop across the transistor. And as we increase the voltage across the bulb, the voltage across the transistor will decrease. Knowing this is very important, since we absolutely must place a heat sink on the transistor. The transistor will heat up because a voltage will fall on it, and a current will flow through it. Therefore, it's very important to install a heat sink so it doesn't overheat. Well, that would be the theory. Now let's see all this in practice. Okay, we've finished the circuit. And as you can see, everything is ready. And everything is based on this diagram. But keep in mind that the potentiometer mentioned must be 1 kiloohm. However, in my case, it's 5 kiloohms. And because it's 5 kiloohms and I don't have a 1 kilohm one, I put a 1 kilohm resistor in parallel with the potentiometer between pin 1 and pin 2, so that this potentiometer works as if it were a 1 kilohm potentiometer. Okay, now all we have left is to connect the light bulb or our LED or neon LED strip. We're going to connect it to pin 2 of the transistor with respect to positive. This point will be positive. So let's make those connections. Okay, we've now connected our LED strip, the negative to the drain, and the positive to the positive of the power supply. Now let's test and see the result of this circuit. We connect the positive. We connect the negative. We're going to turn off the lights. Okay, you can see it's working very well. Now let's look at the voltage falling across the LED strip to confirm that it's receiving 12 volts, and observe the gradual increase. Okay guys, we've now connected the multimeter to the LED strip terminals. We're using DC voltage, and we're starting from 0 volts. Let's increase the voltage with the potentiometer. We have 1 volt, 2 volts, 5 volts, 6 volts, 7 volts, and we can continue increasing the voltage. That would be the maximum voltage the circuit can deliver. We have a small loss, but it's very normal. And this way, you can adjust the brightness of the LED strips according to the work location where you're going to install them. Sometimes it's necessary to adjust the brightness according to where the LED strip will be installed so that it's not too bright or too dull. Okay, now let's test the blue LED strip. We'll connect it and see how it works. Okay, this way, you can adjust the brightness of the LED strips that need to be adjusted. Okay guys, that's how I'll conclude the video. And don't forget that if you like the video, a like helps the channel a lot. See you in the next video. Bye-bye.